I'm going to talk for a couple minutes. John's really hungry, so he's getting something to eat, and then he's going to come out. I'm hoping he's going to tell you a little bit about his history. Some of you I know him. John's one of the best teachers I've had. We talk a couple times a week. I always learn something. On the drive down, I learned a little bit more about his history and him and John Mayer when they were in Switzerland and all kinds of stuff. I hope he'll share some of that with you, and I think he will. But I wanted to give you a little bit of perspective for those of you that don't know much about our company and the relationship with John. Parasound's 33 years old. It's an outgrowth of work that I did prior to that. I've been in audio for about 112 years. Actually, that's true. No, for a really long time. I got in the audio business doing custom installation when I was in high school. As soon as I got my driver's license, there actually always was a custom installation. From the time the first component had a wire to go somewhere, and the spouse said, "No way." Part of what I did before starting Parasound was I developed products for a company that was also a retailer, and that was a very interesting experience. And I traveled to Japan almost 70 times during the decade of the 70s, and in that process, I learned a couple of things. And there have only been a few of us that are manufacturers that were actually simultaneously retailers. Three. I'm the survivor. But what I learned in all of this was how products are made, how they're sourced, the difference between a company that pretends it's a factory that's really a trading company and an actual factory, or who the subcontractor is. And I was pretty determined about that. So that was half of the equation. The other half of the equation was because this group of people that I worked with that had a lot of stores, we were the largest audio company in the world by a factor of 10. Some of you remember the Pacific Stereo chain, because that's what it was. I started there in the original Berkeley store. I was the 13th hire in February of 1965. So having that feedback loop was really interesting because it informed everything I did. Typically, in a situation, let's say a product here, something happens with it. There's a problem with a customer, the product. Normally, the food chain on reporting would be the salesperson here have a problem. He'd tell the store manager, and he would probably tell the sales rep. The sales rep would probably tell the regional manager. The regional manager might tell the marketing manager or the national sales manager, who might in turn tell somebody else. And it's like telephone. It's going to get so diluted by the time it gets to the top, nobody knows what the problem was in the first place or whether the product's appropriate. In this situation, the feedback loop was very direct and it was merciless because my job was to make these guys money. So I learned very early on that you make products that are reliable because no matter how generous your repair, your exchange, your warranty policies are, it's just better that it doesn't break in the first place. That was an important lesson. Some haven't learned it yet. I learned that features have to be relevant to people. You don't put something on there that might mean something to you personally that has no conceivable benefit to the end user. And you learn how to talk about products in terms of what their benefits are, not just what their features are. And that's something our industry could do better than we're doing. So with that background, I left there in December of 1980. It was a long run. I did some consulting for other companies. I was commuting to Southern California once a month for Yamaha. I did a big project for JBL. I helped a guy who actually was associated with this store, a guy named Chuck Kittleson, who passed away some years ago, who worked for us for a long time. I helped him get Proton started in this country. And then I got bored with doing all that and started Parasound in 1981. I missed the accountability of having the products. So we're a survivor. We're still independently owned. We're not a hidden branch of some other company. And for better or for worse, we get to make the decisions about what we build, how we build it, and how many we buy and how we sell it. And unlike a lot of other companies that are either engineering or typically production driven, because that's what most electronics companies are, they find themselves in a position where they need to sell more than they can in a given marketplace or a given economy condition, and find that they have to sell to places they really wish they didn't have to, but they're dependent on that. We don't do that. It's a small company. I went from having 1,851 co-workers at Pacific Stereo at its peak to a couple of handfuls of us that do everything at Parasound. I like it better this way because we get to control our future. That also limits the things that we can do. There are a lot of things that we're incapable of doing that only a large company could afford to do. We pulled out of one of those categories very publicly at the end of 2009 when I just pulled the plug on trying to do surround processors and very publicly confessed we can't do this. It's a business that moves too quickly. It's all about silicon. It's actually more like a computer than it is audio equipment. And unless we could, and I used to say to people, if I did my job perfectly and everything worked out, everything was on schedule, the firmware, the hardware, everything worked the first time, when the product came to market, it would only be 1 year obsolete. And that's playing a defensive game. So we decided we're going to die if we do that. And we doubled down on what we do best, which is technology we can wrap our arms around, which doesn't move quickly, which is primarily analog and the classical way of doing things. So that gives me an entree to go back to John. In 1988, there was a lady named Karen Richardson working for Parasound, and she had a friend named John Curl. I knew, actually, John and I had met in Japan years before that when he was doing a project for Harman with Matti Otola. But he didn't remember. John actually doesn't remember a lot of people. That's okay. She said, you should see what they're doing at Parasound. And John thought that what we were doing was interesting. We were horribly naive compared to what he knew, but our heart was in the right place. So he agreed to do some work for us. I hired him as a consultant in 1988. Our first product that was the result of his labors came out in 1989. And that was our original HCA 2200, which really set the direction for where the company was going to go after that. So I believe, John's longest running gig. He continues to work for us. We've got some things coming up in the future that are pretty interesting that we're not going to talk about tonight because you're all going to buy some Parasound this year, not 2 years from now. But what we're doing, we're known mostly for amplifiers, and that's the title of the presentation tonight. So I'll stick on amplifiers, but I'll answer any question about any product you guys might have an interest in afterwards. We're using technology that's probably 30 years old, and in some cases parts that have been around for a very, very long time that represent what John knows about audio, packaged in a way that it can be affordable to people. So to be more explicit, John's looked into things over the years that don't occur to other engineers or they're not able to cope with as well as he does. There are a few common themes in all of our amplifiers that are from John's inspiration and design. And I'll give you just several of them, and it'll help you understand why our amps are a little bit different than others. The first is no capacitors in the signal path. They're direct coupled amplifiers. John will talk about capacitors because he was one of the first people to actually publish articles about what capacitors do to audio signals and the impact of different dielectric materials and how electrons pass through a capacitor. So direct coupled amps. We achieve that. Usually a capacitor is somewhere in the signal path to prevent direct current from somehow getting out to the speaker because it'll fry it. But the capacitor is sort of like a roach motel for audio. The audio goes in, it doesn't necessarily all come out or come out at the same time. But you need to have something to deal with the bass. So these DC servos, they sit outside the audio circuitry, but they watch it for the presence of DC. And if they sense DC, they'll just basically drain it off, and it doesn't get to the output of the amp. This gives us the opportunity to actually tune what the lowest frequency of that amplifier is going to be. In the case of the JC1s that you're going to hear, they will deliver their full power output, no phase shifts or anything like that, down to 2 hertz, virtually DC. Full power output at 2 hertz. That actually is a palpable difference in the bass response of a speaker, the sense of authority, control, and it's one of the reasons that so many loudspeaker manufacturers use our products, and I'll come back to that in a moment. So direct coupled with DC servos is one. We're also, I think, the only solid-state company that has no output inductors between the output transistors and the speaker terminals. Most amplifiers require inductors so that they remain stable. They don't oscillate and run away and burn up. And John was able to find a way to make the amplifier circuits inherently stable, and they wouldn't need that. So all of the Halo amplifiers have been built without output inductors from day one. Another very, very big part of the equation, and this is where John, I think, stands above most others in the audio business, is his concern over the audible impact of higher order odd harmonic distortion. And we're all, we hear about second order distortion in vacuum tube equipment and third order distortion in solid state equipment. John's concerns are less about that than the sevenths, the ninths, the 11ths, and even higher that wouldn't necessarily be measurable but have an absolute impact on how things sound to us. And the presence of higher order odd harmonics causes fatigue. You don't hear it as something fuzzy or blurry like we normally think of distortion when you overdrive a speaker or something. It's just we don't want to listen to music anymore and we get up and turn it off. And that's the consequence of this kind of distortion. So that distortion is a consequence of having a circuit that is transiting from negative to positive back and forth. It's called crossover distortion or notch distortion, some other things. And the way we deal with it is to basically have the output transistors on a good portion of their range. Now, virtually every product in the store that isn't a Class D is a Class AB, which means there is going to be a trickle of current flowing through the output stage all the time. How much of that idle current determines how much Class A power there is, and therefore the absence of these higher order harmonics. There is nothing to generate them, so they're very, very low level. The JC1's 400 watt 8 ohm power rating, which it succeeds substantially, is a great interest. What interests me more is that it's 25 watts in pure Class A. Given that what you'll hear tonight, even in this space, we'll probably be using 3 or 4 watts, maybe, on average. It's only the peaks, the crescendos, the drum beats, the cymbal clashes, the cinematic explosions that are going to require 10 times or 100 times as much power instantly. But at the low level, where most of us listen most of the time, and all of us with wives listen most of the time, that makes a huge difference in the clarity, the transparency. It's more like you get a chance to listen to music, not audio, if you understand the distinction. And I've heard some really expensive stuff that I thought was great audio, but it wasn't quite music. And I think we do a pretty good job bringing music for the price of the product. This is all attributable to John. And we take these theories, and then we try to give them the best ecology to succeed in. So what do I mean by that? The size of the power transformers, the size of the heat sinks that can dissipate heat, the quality of the parts, the circuit board layouts, the practical decisions that get made. Our front panels are only this thick, they're not that thick. So they don't have to cost thousands of dollars more than they actually do, and we wouldn't want them to, so we don't. But we translate that, and we take my accumulated experience and what our 3 subcontracting factories know about mechanical engineering. All of the mechanical engineering is done where the products are made because it's more practical to do that. To hand a design to a factory that has another way of assembling things is very inefficient, and it's going to cost a lot more. So we build things the way the factories like to build them. And that's one of the ways we can keep the price down. We operate at what would be the ragged edge of mass production. We're not a boutique company. We are small, but we're not a boutique company. So a lot of our products are built in lots of 100 rather than 1,000 or 10,000, which might typify a large Japanese company's products. And we put a lot of investment at the front end of it. So we would normally have to CNC machine a lot of parts. We pay the hard tooling that will punch it, stamp it, or make the plastic moldings or whatever. We put the money in front, but the actual production cost then benefits from it. The other thing we do is what we don't do. We don't try to change our products every year. A, because we can't. B, because I think it's bogus. That's more like being in the fashion industry, and unfortunately a lot of consumer electronics has become the fashion industry. Every year there's a new algorithm for some kind of surround thing you're never going to use anyway, or some new breakthrough invention which is actually which was discarded 20 years ago because it isn't so hot. My staff doesn't like it when I brag about how long these products have been in the market, but I'm going to do it anyway because there's a point to it. The JC ones were introduced in March of 2003. They're still running. We plan to keep running them. Our smallest Halo amp, the A23, celebrates its 12th anniversary in October. It was introduced in October of 2002. And other than some very small parts changes where some parts became unavailable and others came in, like the power supply filter caps in the A23 were changed early in its life, they're the same product. And so we get very high on the learning curve with these products. We get very efficient at building them and making them work right, rather than having to relearn this every year and re-educate an entire industry. There's tons of people that have never even heard what high-end audio can sound like. You've probably all got friends that have come over to your house and say, I had no idea that was possible. At least I hope your systems are that good. We so miss the larger market that makes me even less interested in changing the products every year and trying to re-educate people on a benefit that isn't actually a benefit, it just looks different. So we're really stubborn about that. And there's a few companies that are like that around the industry, and they've also survived in the long term. And I think it's a good reason. It's a lot more satisfying to just refine your craft than try to borrow somebody else's and pretend that it's yours, on an annual basis. So that's kind of the backdrop of what we do. We're in San Francisco. John lives in Berkeley. John will tell you about Carl Thompson, who's not here. He lives in Eugene, Oregon. And he was John's partner in John's earlier companies, and he continues to do the circuit board designs for the products that have the most of John in them, any of our models that say JC in front of it. And John will tell you why there's magic there and how big a role Carl plays and how integral their work is with each other. And that's why we credit Carl's designs on the products, designed by John Curl and Carl Thompson. We build the products in Taiwan, not China. There's a difference. We've been working with 3 contract manufacturers there, one of whom continuously since 1982. That's just not done in audio. Companies hop around from factory to factory trying to find the lowest price, and they end up in China because that's where the price is going to be the lowest. We've been very loyal to this factory, and they do very good work for us. The JC ones and A20 ones are made in that factory. A second factory that we've worked with since 1989 that builds primarily our new classic product and much of the Z, the half-rack product. And then the third is newer, and the gal who runs that company worked for the first company. I knew her 25 years ago. And we're the largest, as small as we are, we're the largest customer for each factory. We get all of their attention, as opposed to going to China and begging for attention because we're not going to buy 1,000 of anything at a time. So, take a walk. We have people checking quality there. When a shipment comes to San Francisco, we inspect it very carefully. We actually had a shipment that came in about 2 months ago. It was a bunch of A21s. We were actually behind, and we had to air freight them in. And we found that some of the black ones had a blemish that you could see if you had a certain light pointed at a certain direction. You viewed it at another angle, you might see something that looked like a little scuff. And we stopped everything, opened them all up, replaced the panels where it was necessary. It's a big endeavor, but we go to that effort to make sure everybody's going to be happy with the product. We service the products in San Francisco. There are also independent service stations, and I haven't kept actual count, but we're sold in over 60 countries, pretty much around the world, and that helps. The export markets are very brisk, and when the economy here is a little slower, that's saved more than one company, and it's a very important component of our business because we get an international take on what we should be doing, and it's more education that I just absolutely love. So having said all that, John, you've eaten. Come on up. He was calculating between the car and car driving down that between him and me, we probably have something like 300 years of experience in the audio business. But
not 300. It was only 150.
Well, so I'm going to step aside and let John tell you a little bit about his past. And he's actually in his old neighborhood right now, and he'll tell you about that too.
Yeah, well, I was raised around here when I was a kid. I went to Campbell Grammar School, which is down the road here. And I went to Camden High School, so I was off in Camden. It doesn't exist anymore. But, it was an interesting time. I mean, back in the 50s and the 40s. I even lived in Los Gatos. Now, of course, I couldn't afford to live in Los Gatos again. And I think they made my grammar school into some sort of institution. But anyway, I went away. After a few years at San Jose State, I went up to Berkeley, decided to hang out with the intellectuals, and I had decided to become, I was studying engineering physics, and I decided that I didn't want to build bombs, And that was the other thing. Everybody was building, step up to big pay, make missiles, and go to Lockheed or something. And so I decided to go into into audio, and people told me, even hi-fi people, with a store that was equivalent to this at the time, say, "What are you, crazy? I mean, audio is not a place to go," But it just kind of shows you when you know what you have a drive and you want to do something, you can actually do almost anything. If you want to be an astronomer, or like I wanted to be an astronomer once, and I was talked out of it in the 8th grade. I found that a lot of my friends who wanted to be astronomers became astronomers. There was some level of astronomy anyway. Maybe they'll become world famous, but they get to work on the telescopes or something. And the same thing happened to me. I realized that being in love with audio and audio quality, that it was easy for me to do well enough, even though they threw me out of a few places. I mean, one time I was sort of thrown out of Hollywood. I worked on this this rock film, and I was such a perfectionist that they really banned me from the studios there. And yet the film came out real well, the sound came out real well. The producers were so happy with me that they put me, gave me a major credit on the film, which wasn't really negotiated in advance, because of the sound, because we were able to do it. But it wasn't easy. So you have to take these people's attitudes that, who cares, kind of like MP3 kind of mentality, and and it's true, and about that time, in that time period, I originally, and I got out of school. It was easy to get a job, and at one point I got to work at Ampex, which is up the road here, and that was the greatest job. I mean, I really enjoyed it. I designed the tape recorders, analog tape recorders. And the place was a real high-powered place, and that was really important. They had a great library, and I could read, and study and get copies of everything, and virtually everything in audio for 20 or 30 years previously was in that library. It was about the best audio library there ever was, I think, that I know of. But, as time went on, I found myself working with the rock groups, and they wanted stuff. They had vacuum tube stuff that really sounded pretty good, and what they wanted was solid state stuff because they wanted something more roadworthy. Every time they took the stuff out, even if they padded it, and they really did, they put it in big canisters. They take a big Mac 350, which is this 3500 is great big 350 watt channel thing, and a vacuum tube, and you could put it in foam all right, or not the hard foam, but the what do we call it? The stuff that like you might sleep on, and it wound up breaking anyway. I mean, the tubes just couldn't handle the jiggling and the air, the air travel. And so they said, well, look, we'd really like you to try to make some solid state stuff for us. And this is like 1970, so it's a while ago. And so I thought I could do it. I thought, oh yeah, well, that's easy enough. I'm an engineer, I can do these things. So we started making a studio board. We made this studio board. And, we got it all done, and Grateful Dead, who was my sponsor for this, took it on the road, and they were using it for a while. And one time, there's this guy named Osley. You may have heard of him. I don't know. He used to make chemical stuff. And he was the manager for the Grateful Dead, too, at the same time. So he decided that the darn thing didn't sound right. So he decided maybe it'll sound better if we put it on batteries. So he gets a bunch of batteries, and he puts them in backwards. And he blows the whole thing up. And he has to go back to the tubes. So they go back to the tubes, because they had it in reserve, because they had to do the concerts. And they listened to the tubes again. They said, hey, yeah, we're not going to go back to that. That thing sucked, man. I mean, well, and they basically fired me, politely, but they did, like, oh, you can't do it either. And yeah, I had to learn. I had to learn a hard lesson. What it measures like is not all that it is. It's got to sound good, and often that's behind. There's more to it than just engineering. Engineering is kind of a cut and try kind of thing, and the physics is more like the essence of what's really working, what's really going on. And I had to dig deep. So I read this stuff that I was a member of the IEEE and the AES. Those are the different engineering organizations for this kind of thing. And I read this stuff by this guy in Finland named Matti Ottila. And, it was pretty crazy. I mean, but, the guy had said, hey, I found an answer. I can make stuff sound better. So I looked at the stuff, and I looked at the way he did it, and it made some sense, but it wasn't easy. But then the Grateful Dead invited me back. In other words, I'd gone, worked with them for a while. They let me go. I started working on this rock film. I got kicked out of Hollywood, as I said, in between. And then when I came back, they said, hey, we want to build this big sound system called the Wall of Sound. Well, it's going to be just huge. It's going to, be the whole, we're going to use the whole back of the stage for the sound, and then we're going to keep it from squealing or feeding back by using special noise-canceling microphones, kind of like you've heard of the headphones that do that kind of stuff. Well, there's a way of doing it with microphones. So, okay, so we did this huge thing. It was just, way above the ceiling here, I mean, it was really big. And they wanted me to do the electronics for it. And I thought, well, I'm going to try some of this guy Ottila's ideas, along a couple of mine, and let's see if I can do it this time, because I didn't do it last time. So in 1971, I didn't do it, so this is 1972, 73. Can I do it? And I did it. And so the first thing I did is I made this design, and we listened to it. It sounded pretty good. Everybody was pretty happy with it. We had to get it built. We had to get a bunch of them built because we had it's like we had to have 25 of them made. And I'm not going to sit there and hand solder them. So I just happened to meet up with Mark Levinson. This guy, you've heard of him, and he's a young dude, man. And I'd met him earlier, but he remembered me, and we met at an Audio Engineering Society thing, and he says, hey, I'd like to work with me. He says, I'm living at my parents' house and working out of their basement, but what the heck, So I start working with him, and I said, well, the first thing is I saw the quality of his work. He really made beautiful things, even for the time. So I said to myself, well, let's, Mark, you make beautiful stuff. Maybe you can build these little modules for us. So the Grateful Dead, and we'll pay you, of course, and then you'll have that. So what happened was, Mark built the Grateful Dead modules from the schematic, And, you know, he delivered them and everything. They were just real pretty little things. And then the Grateful Dead was happy, but at the same time, Mark Levinson said, you know, these modules sound so good that I think we ought to make a preamp based on these modules. And that became what's called the JC2. And there was a JC1 in between. That was a different design, and it was very successful too. But it was a preamp. It was a special thing. So what happened was we built this, you know, he decided to incorporate what the Grateful Dead had basically paid for, you know, and the design. And we put it into the JC2, and then he built the whole thing. And then JC2 took off. And, you know, we were competing with some pretty heavy-duty, you know, stuff. I mean, audio research is no slouch. And there was some, you know, and they had vacuum tubes. That's a real advantage. And we went forward, and we were head-to-head with them. And even with the magazines. And that's where it took off. And, of course, it made Mark take off, too. And then I was known, you know, Mark decided that, well, I'm not going to hide the designer. I'm going to keep him. He was sorry for this later, by the way. He really was. He was ticked, you know. That's why the JC2 became the ML1. I mean, there was a reason for that. And he didn't like that, you know. I mean, he wanted it all, you know. And so... but you know, we got going, and we were successful. We realized both with the Grateful Dead, with the rock groups, and with the audiophiles, the serious audiophiles, that we could make something that sounded pretty darn good with solid state. And that was the test. So we knew the vacuum tubes could work pretty well. They really could. They may not be, you know, so much for power. I mean, it won't be a JC1. I mean, those JC1s, I guess they are, aren't they? Yeah. They couldn't, you know, it would take a huge, well, not necessarily extra huge, you know, maybe 4 times the size, I guess, to make, you know, tubes to do something like that. But what was I saying? I've got myself confused.
Size, power.
Yeah, well, of course, solid state is more efficient and more rugged. And the main thing that we had to do, still with power amps or preamps or anything, is to make it sound so that it sounds either completely neutral, so that it doesn't bother you, but it doesn't have any edge. We can't put any edge on it. And the edge is the trick. That is the thing that causes, I think, in solid state, one of the most important things. It's not the only thing, but it's one of the things. And one of the things that transistors tend to do, bipolar transistors especially, and that was the predominant type of thing when I started out. FETs became a little bit more... they appeared virtually in a useful way about the time I started working with the Grateful Dead. But the thing is that they tend to create a certain amount of 7th harmonic distortion. Now you may think, so what, you know? I mean, 2, 3, 4, 5, 6, 7, you know? But it just so happens that 7th harmonic distortion is completely inharmonic. It's like, it doesn't match anything. You can't tune to it. You know, they have these ways of adjusting, you know, they can, you know, whatever. What do they call it, Richard? When they change the tuning to fit.
Pitch shifters.
No.
Adjusting the bias.
Tempered scales, you know. They have ways of adjusting these scales to make them maybe a little bit different from the mathematical purity, but they don't get dissonant. But 7th, you can't do anything with, for all practical purposes. Maybe you could make some strange sounds or something. But the thing is that there was always this 7th harmonic that was coming out of the most of the sound systems that we had, and of the electronics that we were making. So, and it was very hard to get rid of that. In fact, that's one of the things that I try really hard with these types of designs, like the Parasounds, is I work on making sure that the distortion pattern is really, really low level, low, like second and third harmonic. Those are virtually music by comparison. But fifth is, you know, fourth is just the octave above, or the double 2 octaves above. What is it? 2 octaves? And then, but fifth, it gets a little bit dissonant, and then sixth, I don't know where that's at. It's at third, but I don't know. It's not too bad. But seventh is death. Okay, so what I do is I put on my equipment, I measure real deep and look for that seventh harmonic distortion. I don't know what I'm holding this thing for, but
above what percentage of seventh is objectionable?
Well, interestingly enough, 75 years ago or so, they determined that almost any seventh harmonic distortion was terrible. If you look at the Radiotron Designer's Handbook of 1940, you will find that they say any measurable seventh is too much.
This is the Australian book that you're...
Yes.
Big fat red one.
Yeah, that's right. You check it out. Now, the big fat red one was the later one. That's like 53. But in 1940, it was like this, but they said the same thing in both books. They took the same thing. And they even, and back in the middle 30s, a guy named Sir James Jeans wrote a book on music. And he talked about the different orders of distortion. And he says, and seventh harmonic came up, and he says, man, it's not good. And then they showed how they designed pianos to remove seventh harmonic distortion. That they actually put the string of the thing, they put where you hit it in a certain percentage place so that you could null the seventh harmonic. Or the ninth. The ninth's not so good either. Sometimes they mix them between the two to get the best fit. But they actually null it. They work on it to get rid of it. So, but seventh is really death. But it's not the only thing. It's just one of a number of things. But I have to go one after the other after the other. My first thing with Parasound, and in fact, I'd never really built a big, powerful amp until I worked with Parasound. And Parasound started me out with like about 200, 250 watts. So it was like I had to make it work. And one of the ways we made it work is we ran them warm. But there are some tricks in the design where you get the best fit between what we call Class A operation and Class A-B operation. You can't build a Class A amplifier like this with more than, let's say, 100 watts, except by actually compromising it and making it a Class B amplifier. So in this particular case, it's like 25 or 30 watts. Are these really chasing ones? I can't tell anymore. I'm half blind, by the way, if you don't know that. The thing is that we can only make it Class A up to a certain point, and then we have to go into Class B, and then we can Class AB really, but that transition is really critical, and it's hard. It's not easy to do it right.
It results in distortion.
Huh?
And it results in distortion.
Oh yeah. Well, the thing is that when you have one device running, it's doing everything, and if you have the other device running, the minus device, set of devices, they're running. But when you mix them together, you actually get them working together, and you got to make them work smoothly together so that they don't bump up or and do too much work. Do too much and be like jerk the thing, jerk the transfer function. So it's one of the tricks of the trade it's not a big secret really. I mean, people known about this. There was a vice president at Hewlett Packard who wrote back in 1971 how to do it. It's just that nobody reads the stuff, you know. I read it and kept it, you know, and kept it in my memory. And now people fight with me even to this very day. I got people on the line, you know, they'll say, "Oh, you shouldn't use that. You shouldn't do it that way," you know. And I say, "Well, you know, I have success, you know. What the heck?" Both measured and sonic, you know. But that's, you know, over the years I built a whole lot of things. I built master tape recorders and studio boards, like for Crystal Clear Records and for Dave Wilson Audio, for their mastering, you know, so they could master with it. And they found that I could make, I found, or it was found, you know, not just me. I mean, I was told by people who use this stuff that it worked. In fact, I was told once that one of the studio boards that I made is a special board. It was actually sold or actually donated to Stanford University Audio Research Group. And they used it and for demos. And Sony banned it from one of the demos. It was too clear. Showed too many problems, I guess. I wasn't there, but that's what I was told by the professors that came back to me about it. And but I've designed mastered analog tape recorders. You know, because I'd worked at Ampex and analog tape recorders, I was able to design them. I wanted to, you know. It was a really cool thing to do. It's a lot of money, you know. It costs thousands and thousands of dollars to do that kind of custom work. But I got the, I built a couple, 2 or 3 machines that just ran balls out, we call it, you know. And that was 30 inches per second, full track. Now, that's the kind of speeds and bandwidths or tape widths that Hitler would have used, you know, to do his speeches. I mean, it was like way back when, you know, when they first started the tape recorder, they said, well, we got to have this. And of course, tape had improved since then. So but it was physically possible to do it. And so when we did it, all of a sudden, man, we came out with wide bandwidth and really super low noise and low distortion and good square waves and everything that you could ever ask for, just about. And Dave Wilson made most of his recordings with that, Wilson Audio. And they actually took the darn tape recorder. I couldn't believe it after, you know, it was long gone. I mean, it wasn't in my possession or anything. Dave Wilson rented it to Sheffield Records. You may have heard of them. Sheffield lads. And they took it to Moscow to do the Moscow Philharmonic before the Iron Curtain fell. But they needed the best tape recorder around, so they took mine, which I was very proud of course. The only thing is, when I came back, it was full of cigarette nicotine stains. I swear I had to clean her up, you know. And it's just, well, that's part of the thing, I guess. But the thing is, the key to it all is you got to kind of know what you're doing. You know, I have a degree in physics, and that's not saying very much, really. It was just, I never did atomic physics. I just sort of did Newtonian physics, you know. But the thing is that I learned everything I could possibly learn. When I was at Ampex and even before, I read every journal, everything that was in front of me. I spent my lunch hours. You got to put your 10,000 hours in, as they say. I don't know why. Just you do. And you got to believe in yourself. I mean, you got to believe in this stuff. If you don't believe that there are any differences, then, you know, am I kidding myself? Are we all being blinded by this? Could we really get away with a Bose, whatever, you know, I don't know. You know, I don't know, you know. I mean, I don't think so, you know. I think we know. You know, I always say, my motto, and it's really a real, and people get annoyed by this, I say, trust your ears. Whatever, trust your ears, you know. And not only your ears, but especially as we're getting older. I mean, I'm 72 years old. I mean, I'm not exactly a chicken, you know, a young chicken. I want to say that I trust my friends' ears as well, colleagues. You got to trust your colleagues as well. If your colleague says, hey, you know, I've heard blah, 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 you know, trust them, you know. At least trust them as far as you can, and within the realm of reason. Try to verify, you know, trust but verify, kind of the Ronald Reagan thing. But the deal is, you know, they're not lying to you. You know, they hear it, you know, and they may hear something you don't hear anymore. I don't think I hear as well as I used to. I hear pretty well, but I don't hear as well as, you know, 24 years old or something. I mean, it's almost impossible. But anyway, what can I say? I've kept this standard with everything that I've allowed my name on. So if I'm associated with it, at least I try hard and I have some input into trying to keep the thing in alignment. It's hard sometimes. See, I have to deal with the guys over the ocean there, and sometimes their engineers don't believe in everything I believe in. They'll sneak something over. I tell you, it's happened over the many years. And I've had to tell Richard, you know, I tell him, guess what? We found blah, 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 you know, and he's got to go back to them. And sometimes they even violate written instructions, you know. Huh. Well, they take it, what the heck, what's the difference, you know? Connector's a connector, what the hell, you know? We can get this Chinese knockoff, you know, that's so magnetic that if you put a magnet here, it goes bang, you know? I mean, you know, and it looks just like the real thing, you know? And
I trust my ears.
You trust your ears?
I was talking about his cell phone.
Well, yes.
John, I have a question.
Sure.
First of all, thank you. I own one of your Parasound amps. It's beautiful, and I bought it after a huge amount of research, and I read some of what you said. And I'm an analog guy. I grew up in Berkeley, shopped a lot, etc. Before they.
Well, that's where I live, the People's Republic of.
And I've always thought the hardest thing, if I ever were to build an audio amp, which I always managed to stay away from, was the crazy impedances. How do you deal with a speaker that can reflect anything at any time?
Well, I'll tell you, I tested these amplifiers on one of the worst speakers that I've ever known about, and that was a original Wilson Audio Tiny Tot, or Watt. And it had an impedance at 2,000 ohms, 2,000 ohms, that's silly, 2,000 hertz of less than a half an ohm. And he'd made a mistake. And what he'd done is he'd put a resonant sort of thing to kind of knock out some of the phase shift. And it was a dead short, you know, right at the, I think he was trying to, I'm not absolutely positive, huh?
That knocked it out for sure.
Well, we knocked it out all right. Darn near knocked out most, and then he was using a big Krell or something when he was testing, and he didn't notice any difference. But boy, I tell you put that thing on some of the amplifiers. I mean, I even heard one amplifier I had, and it was a very good amplifier called an Electro Compagnette. And I liked the sound of it. But when I put it on the speaker, it started singing at that frequency. You know, and I had to put a half ohm resistor in series just to kill it, you know. And I ran it that way for years, though. I mean, a year or two. But he gave me a pair of Wilson Audio speakers, so I couldn't look a gift horse in the mouth, you know. I just had to live with it. But once it was destroyed, I was in a firestorm and I lost the speakers. I went out and bought another set, used, but I bought a pair of these Wilson. And that for years, until just this year, that's all I used. And this darn thing would go drip, you know. And boy, talk about a test, you know. Almost all the amplifiers, in fact, you know, that's a tough test, is when the darn impedance changes so radically. Now, I don't know why they have to change so much. In fact, I've designed speakers myself. I work with this guy, John Meyer. You may have heard of him. And we designed speakers together in Switzerland, and we used to work together. We used to sell clip shorts. We used to work in a place like this. It's called Berkeley Custom Electronics, okay? It was just a little hole in the wall by comparison. But we sold clip short and Marantz and Mac and tube stuff, you know, and Ortophone, and we were pretty uptown. We were the most uptown there was at that time, back in the 60s. But we learned the idealism of audio. Now, Richard over here, he worked for my competitor, didn't you? You worked over the other way, and you were in a different world, I think, than we were.
No kidding.
We were the idealists, you know. We were, oh man, you know. But you know, both this John Meyer and I, we both did the same job. We didn't work together. We worked one after the other, and he learned like I did, a love for the getting it right, getting the sound right, and what audio could give. Because we were listening to triode amplifiers. I mean, my old boss, the guy, he had a bunch of triode amplifiers. He got them around, you know, like, you know, what we'd pay, you know, thousands for now. He had them sitting around, you know, playing the radio, you know, playing FM radio, you know, music or something. And we'd listen in the back, and he never hurt our ears. We were young guys, you know. We realized, this is good. This is smooth. There's something right. What?
I want to get back to your actual question. How do you deal with that stuff? When I was consulting for Yamaha, they had a new power amp that had just come in from Japan. It was an M70, I think they called it, and they had a pair of Infinity somethings. Anybody who's ever owned Infinity somethings know that they achieved their sound quality at great expense of the amplifiers. Anybody who's got Kappas would find that out. And so they're very proud of this new amp. It was actually quite pretty. And they hooked it up to the speakers, and it made an astonishing reading light for about a nanosecond because the speaker had such a punishing impedance curve. So the answer to your question is actually kind of brute force and high current. If I had my way about the audio industry, we wouldn't measure the products in watts. We would measure the product in amps for their current. And the JC1 uses nine pairs of output devices, big ones, big husky 250 volt Sanken transistors for the maximum safe operating area. So we actually accomplished more than we'd hoped. The amp is rated at 400 watts at 8 ohms and 800 watts at 4 ohms. We also rated it 1200 watts at 2 ohms, and it will drive apogee scintillas, which were an average of 0.9 ohm. Probably before most of you were that involved in audio, big planar things, but horrible loads. And one of the reasons the JC1 and actually all of our amps became as popular as they are is because they'll drive anything. They're not quite an arc welder, but I don't think there's a commercially made speaker that will challenge these amps or even cause them to break a sweat. So it costs money. You got lots of these things, they're expensive. You got to have heat sinks to dissipate the heat. You've got to have a power supply to feed some juice to them. And ultimately, all they're trying to do is make the best use of what's in the wall to come out at, the speaker.
Have you ever been tempted to build your own speakers so you could match your amps to your speakers?
It wouldn't make any difference because we have to design it for everybody. We have to design the speakers to drive electrostatics. One of the biggest things for the JC1 are these great big electrostatics. They love them. I have friends who have, 4 or 5 of these things, driving their big electrostatic speakers. One of the companies, what's that? Sound Lab? Yeah, they own a pair of these these amplifiers. They use them for.
They're dealers who are mostly people selling.
We designed it for them. We designed it to fit in there. It's over-designed in a way. It's like pulling a trailer or something. This thing is capable of pulling a trailer. Comparatively speaking, if it has to, it'll do better if you don't have to pull a trailer. But it's designed to do that.
Then you have to compensate for a speaker designer who screws up.
We do.
If you did your own speakers, you could do a good job on both
No, but
sides.
that's I designed speakers for a while. I know, and I'm not good at it. Honest. I can make them measure flat, sound good, and I'm time aligned too. Low distortion, yeah. Sound, that's magic.
I think depending on building your products to be able to drive anything that's commercially available, and there's some really weird stuff from little niche companies, ends up paying a lot of, has a benefit for speakers that are actually more reasonably designed, like these Paradigms. The reputation for being able to drive anything is very closely related for how reliable the product is, because it's not stressed. If you read the magazines and you look at the test measurements, like John Atkinson in particular for Stereophile, there are very, very, very few high-end amplifiers that'll meet their rated power. Virtually no tube amplifiers ever will, but in solid state, big thetas couldn't come close to their rated power because they just didn't pay attention to this. They didn't think it was important and probably didn't have that much feedback to realize that you've got to overbuild it to be safe anywhere that it might be used. And that includes homebrew things which aren't very well thought out that can be horrible for amplifiers. But these have to work anyway. If the amp fails, I've got the same problem having to get this thing repaired and take care of it. So just avoid it in the first place.
I think it also should be said that Richard and Parasound has a real advantage. In fact, it's one of the things that we utilize, is that because we work through Taiwan to have these things made, we get the parts. They have ways of getting parts, like multiple company kind of discount kind of deal, where these the companies who actually fabricate this design may actually build several other companies' designs, but they can get the parts, they can source the parts so reasonably that we can't even come close in this country. If we try to do it like here, it would just be, we couldn't buy the parts for what we can get the whole thing made for over there and shipped to us.
The biggest advantage for Taiwan isn't cheap labor, because there isn't cheap labor there. It's, sometimes I'll tell people, like, where's your Class D amplifier? And I say, well, we do our best work with copper, aluminum, and steel, because the prices there are very competitive. So huge transformers in these that have big steel cores and heavy-duty copper windings cost less to make there than they do from Plytron in Canada, for example, a well-respected transformer maker. The extruded heat sinks cost less. One of my young engineers was over there recently taking some photos in one of the companies that makes the front panels for our products, and he's got a really nifty photo of the front panels that go on the $85,000 pass stack coming off the same equipment that's making our panels, by the way. But if you talk about parts, there are very few parts built here anymore. You might have American brand names and you might have American distributors, but the parts are built somewhere else. So it's actually, when you see a product that says made in USA, it's frequently kind of disingenuous. Maybe it's assembled, but very little is actually manufactured here. We're just kind of upfront about it, because people would wonder, well, how could you do this? How can you provide that product at that price? That's how. I also drive a turbo diesel Volkswagen and not a Ferrari, so that's how too. But there's, this is all very rational, and it's a product. That's when I was working for somebody else, and it was fun. I couldn't get in and out of it now. But this is all stuff that you just accumulate. You don't go out and do this and get there without having made a lot of mistakes. So I'll pride myself on saying I've made more mistakes than anybody, but that's given me more learning opportunities as well.
Yeah, Rich is one of the hardest working guys I've ever seen. I went over to Taiwan with him once, and I couldn't believe it. He was just all over the place. But, he's lost his health. That's what happens, Yeah, well, I'm kind of lazy that way. I just like to sit around and think about things and get on the computer. I do everything on the computer. I mean, I really do. I never go to work. I mean, I haven't been to his shop or his place once every 10 years, maybe.
I have just a general industry question. So you look around this room, most of us are middle-aged, and I have young kids, and my kids have no appreciation for music. They are purely, MP3, Apple. So where do you think this is going to be in 20 years? I mean, do you think there will be a...
That could be my problem in 20 years.
I know, but in general, I mean, the generation has changed. I mean, people don't listen to music anymore.
They will. That's like fast food. The kids are listening to music. They just
But
listen
they don't
to
listen.
it. Like,
No one sits in a room, in my opinion, in front of a speaker and listens. It's all surround sound. You're moving through the rooms. It's just, I think these kids are consuming music differently.
I think you're actually asking, you're asking an interesting question, but I think it's even broader. At the time when, John's a couple years older than me, but at the time that audio was blossoming, and there was kind of a congruence between a few things happening. One of them was solid state product was starting to work. The other was the FM stereo multiplex broadcasting became popular, and people could hear well-recorded, spacious sound. And the third was the role that music played in our society. What was going on with Vietnam at the time. All of these things, society was very different than it is now. We can stay away from politics, but the point is that music at that point was very much a destination. And now these days it's more of an accompaniment. When I sold retail, and there'd be a group of people listening to whatever it was we were demoing, and I'd eavesdrop on their conversation afterwards, they weren't debating whether it sounded good or not. They were talking about moving in together so they could chip in to afford it. Because for a lot of people at that time, it was the largest investment they had made. They hadn't yet bought a car, and some never would. And they hadn't yet bought a house. The audio was the most important thing for them, front and center. I think that there's a number of things that have happened, and one of the things that I'm imagining that a lot of us here share is that the enjoyment of audio is kind of related to how much we like it and how much we value the ritual of the hunt of finding the equipment that we like, sharing it with our friends or learning from our friends, discovering their music at the same time. And the things that you have to do, you need to be careful with the equipment. You have to know how to position it to sound right, how to hook it up correctly. If you're playing LPs, there's a real ritual involved in that, which is kind of, you give yourself a timeout from whatever you were doing to get the disc, handle it. You can't help but see the cover art, clean off the stylus, put the stylus in the... All of these things take time, but it prepares you for the kind of enjoyment that you don't get when you go to an MP3 file. And I've got a little laboratory. I've got a about to be 24-year-old who was a conservatory and college student, and he and his friends. It's interesting how quickly the awareness of the deficiencies of compressed MP3 files getting around. Now, there's some segment of young people who are skipping high-res files and going straight to vinyl. Vinyl, I think, enjoyed a 35% sales increase last year, according to Michael Schram or something like that. That's interesting. I don't know that that's the big picture. I think it is going to end up being the high-res files. But I think that as people settle down and calm down a little bit, and the music has an opportunity to have a different relationship with their lives, their interest in how they reproduce it's going to improve. But all of us in the audio business talk about this all the time, and what we've given up and a sense of jeopardy about it.
You know, that is a really important area. It's vinyl, and I've always been a vinyl kind of guy, and I know it's I just like it. I always have, and I never liked digital very much. Still don't, and I'm sort of sorry about that because it takes away some things that I could really kind of maybe have a little bit more exposure with, a little bit more musical exposure, because I say, well, do I really want to listen to it on a CD or something? Sometimes CDs sound just fine. I mean, I have to admit. But sometimes it just grates at me. And I try to get better digital. In fact, I actually worked as a consultant for one digital company, a Blu-ray company, recently. And, I can sort of see what the problems are. The problems, not that they don't try, but they're so spec conscious. Man, one little decibel of spec is everything to them. The sound, if they can't measure it, they don't believe it. Even if it's other people will take apart their same equipment, like on the internet, they'll take apart the they'll say, okay, you get it, and then you take it apart. You take this out, you change that, and well, it should be done in the first place. Of course, that's why they hired me originally, was, hey, maybe you could help us do this Yeah, but once I told them, they didn't believe me either. You know, it's true. I even told them what I heard, and they said, "Oh, how dare you?" You know. Yeah.
I've been pondering how to ask you this question since I heard about the seminar, but you touched all around it. It's the holy grail of perceived audio quality versus specifications, which is a hackneyed subject, of course. But I am not a rich audiophile, never have been, but I struggle in my mind. This is, sorry for a shaggy dog question here, but I go to audio shows and I'm drawn to, you know, crossoverless full range speakers driven by filamentary Class A triode amplifiers.
They sound pretty good.
Playing vinyl and stuff. Yet I know intellectually that all that is much higher distortion, and, you know, and I go, am I just in love with euphemistic distortion?
No.
And so then I tell myself, well, I really can't hear it in the stuff that, you know, high rate digital and ultra good spec equipment should sound better by reason of measurement. And I know you've dealt in the area of measurement versus your ears. Can you give any kind of sense to why we are attracted to things that don't spec well but appear to sound well?
Well, to be honest with you, I've been in exactly your position. Sometimes I can go, and even with all the solid state around me and everything, and it's like I can go into a show and I listen to a triode setup, you know, really nice. And it's just nice. I'll sit there in comfort.
One of my dirty little secrets is that I ran a pair of quad ESL 63s off of a pair of Marantz 8Bs for years making this equipment, which I adore, but I love those. And I couldn't justify them on paper in a minute, but they sound like music.
Yeah. There are some theoretical reasons for the differences. I try to work with those differences too. There was a test done by a Japanese professor 35 years ago or so. He published in the Audio Engineering Society, and his name was Dr. Hirata, and he was at some major Japanese, Tokyo University or something like that. And he came up with a different type of test, and it was in some ways closer to music. It was it had an asymmetry in it. In other words, instead of having a sine wave that just goes up and down evenly, even if it raises level and lowers level, it was built so that it would be higher on one side and lower on the other, except that it would average out DC-wise, because you'd get a DC offset, you know, shift, if you don't. But the thing about it is that you run it through this test, and you could actually run it through loudspeakers, and the loudspeakers were immune to this type of distortion, but amplifiers were not. It was very interesting. You could even test the amplifier through a loudspeaker with a microphone and see the problem. And guess what? All the solid-state amplifiers of the early day Crowns and stuff, they all went bad. Marantz did great. You know, like his 8B, it did great with the same test. And they did the static test as well. Then they did the Hirata test. And the Hirata test was such that it seemed to be able to tell whether it was going to be right or not. Now, interestingly enough, I started building something in a certain way. I wanted to null out a little bit of distortion that was left after making everything perfectly balanced as best I could. There was always a little bit left, and I wanted to fine adjust so that I could get rid of it. It's called an AC balance. And I built it into this little amplifier card that I was making for the master recorders and studio boards and things like that. So I built it in, and I put it on the Hirata box. And interestingly enough, when I had the AC null connected, it measured worse with the Hirata test, but it measured perfect with a harmonic distortion test, because I could balance it out. Almost no distortion. So what's the point? I mean, I just took it out. I just said, oh, I'll live with a little bit of second harmonic. Now, the thing about distortion is distortion has to be weighted, and it's a very strong weighting factor. Second and third harmonic are almost music, as I said. If it wasn't, let's say third harmonic sometimes is complained about. They say, oh, third harmonic, it's really bad. No, we could never have listened to analog tape or anything that came from an analog source, because an analog tape has like 1 to 10% distortion all the time. What are you going to do? You're listening to it and you hardly even notice. Why? Because it's pure third. And if it gets anything to even fifth, then you start noticing, there's something wrong. But that's what it is. I mean, I used to design these tape recorders. I mean, I know I tested 100 times. And it's amazing how lousy analog tape already was. But it worked. Same way with a record. A record mostly has not third harmonic, but second harmonic. But it has plenty of it. But for some reason, it doesn't seem to make that much difference. When I really want to listen to music, I listen to a record. I would do tape, because I used to own a master tape recorder, and I still do, in fact. But my master tapes that I made over the years were destroyed in a firestorm. And after that, I just, what can I do? Everything I own, bookshelves and bookshelves, lost. So I gave up on analog tape, even though I own a bunch of analog tape recorders. I don't know what I'm going to do with them, but it's analog tape. A master analog tape sounds wonderful. It sounds even better than a record in some ways, all by itself. But once you take the analog tape and try to put it into a record, then you got a two-stage affair. Direct disc is still better, because that way you only have one effect. You don't have both. It's almost impossible. In fact, with Wilson Audio, and he's very happy with it, he was able to utilize my tape recorder, which was as far out as I could make it, burn tape like there was no tomorrow, I mean, $50, for 15 minutes or something, And you just have to eat it, If you want it, the right stuff, you got to have it. You got to go for it. Half-inch tape, not this quarter-inch stuff, and it's got to burn, at 30 inches per second. It's expensive, but if you're mastering, it doesn't matter so much. But even that, trying to transfer it over to a tape recorder is not quite the same as direct disc. Direct disc is still better, just by a skosh, but still better. At least my personal opinion. Now, digital is getting better. We've been worrying about digital. We're trying to do digital. It's getting faster. It's getting more bits, more everything, more linear, on and on and on. But I've been after it for 50 years almost. And I'll tell you, digital still doesn't quite make it with me, but it will be the only practical way in the future. Maybe these downloads or whatever. I haven't tried the download thing recently, so I don't know. Yeah, you in the back.
So I said I'm a digital guy, and I bought hundreds and hundreds of high-def recordings, of which I would say I have, on one hand, good ones.
Really? That bad, huh?
Yes. Most of them are subpar, but the good ones are truly bring back the memories of vinyl, or even cleaner or better. There are some amazing recordings, but not very many. So I think that the art will catch up.
What do you think is wrong?
I don't know. I can't. I'd probably be rich if I knew.
Mastering.
Yeah. Well, obviously mastering can wreck
still.
anything, but Pro Tools, you can go crazy and wreck anything. So I do think it has a lot to do with mastering. Good mics, good preamps, good everything. But I have a handful of recordings that I would say that are as good as anything I've ever heard on anything.
Yeah, I've even heard some good CDs. I mean, I got to admit, I've got a few CDs that are just wonderful. It might be the quality, the type of music. I don't know. Anyway, go ahead, sir.
Of course, the thing that I've heard a lot about lately in the digital front is something called DSD, especially double DSD, which there is Sony, and especially is directing some of their corporate energies towards getting out there. And that probably,
DXD, is that what you said?
yeah, DSD, direct-to-video
DSD
digital.
or double, yeah.
And there's also a local recording company that specializes in recording in that medium.
Yeah, well, if you get it fast enough. I mean, I actually did a interview for the Absolute Sound back in 1980, of all things, huh? And they said, what's wrong with digital? They asked me, so I told them a few things. And I said, they got to at least double the sampling rate. I said, 44.1 is ridiculous. I said, you guys may not even realize why 44.1 existed. It wasn't the professional audio people that did that. It was Sony. See, Sony had to have a certain frequency that fit their video tape recorder, the little Betamax thing they had that they used as a recorder. And they had already made the video thing, so they had to get it to sync properly with the right frames. Why is it 44.1? Well, that was what it took. You couldn't use 42, 44. You had to use 40.1. And then they said, well, we'll make it work. And they did sort of make it work. They did a lot of work involved. And they proved that you couldn't hear any difference, and they do all this stuff. And of course, today, they're turning around. If you actually look at some of the Sony stuff, they say, well, we've done greater things now. We've obsoleted our previous work. Well, about time, But we could have told them there were problems even then, long 30, 40 years ago. Yeah, go ahead.
So, a question about gain structure of a system. I have a line stage that has 12 dB of gain. I find most power amps are 26 to 32 dB of voltage gain, and that's too much in my system. Why?
Why it's that way?
Yeah.
It's done for practical reasons for home theater, normally. In other words, we use 28.2, I think it is. Guess what? It means you put 1/10 of a volt in, you get a watt out into 8 ohms. If you put a volt in, you get 100 watts out. It's simple stuff. Now, you could, in theory, the people who don't have to do the home theater standard, they can use any voltage they want. They can use times 10 or times 20. Usually people don't use more than 28. It does get a little bit ridiculous. Although in Europe they used to use more for some reason. It was done way back when, a standard maybe from the 40s. And
I just hate throwing gain away because you added noise whenever you added gain. Right, so
you don't have to learn. You don't have to lose anything. With a feedback system, you don't lose anything by putting more feedback in. If you can afford, don't destroy that. If you don't go unstable or something, it's okay to set the gain anywhere you want.
Your question is interesting though, because our amps have roughly 28 dBs of voltage gain, and the JC2 is either 12 or 14 dB of gain, and frequently, if people have hot DACs with 5-volt outputs instead of 4, balanced outputs, that's what the trim pots are for. On that, is to be able to reduce the gain by 10 dB, and then you get the volume control in a nicer part of its range, and you don't feel like it's so touchy to use it. If it were up to me, that preamp would have a gain of 4, but there are amplifiers that have lower input sensitivity, and we just have to allow for that.
Well, it's more than that. The design itself doesn't allow itself to be really, really low gain. I know that sounds very strange, but what happens is with a balanced, the JC2 type of design, it basically has 2 outputs, and one of the outputs is actually, it's like A. Let's say your output is A, gain of A, 10, 20, whatever. Well, the other one's A plus 1. And so we have to put a correction circuit in there to create it so that it goes to, when both outputs are A. They're not A plus 1 is tuned down to A. And when you try to choke it down to, let's say, a gain of 4, it really gets off. And you have to throw away a whole bunch of dynamic range on one side just because you have to throw it away. And it's a tricky, it's been fixed. It's a fixable problem, but it's a very sophisticated fix. And our way is easier. So we have to have a certain amount of gain, intrinsic gain, in that design, that type of design. Now, other kinds of designs, maybe not. We could go, because we don't want too much gain anymore. That's one of the things. Since we put the gain in the power amp, we found that 20 dB a gain, which was the standard of the industry for, eons, was too much. And so we went down to 14 dB or so, because that's easier.
Is that open loop gain or gain after feedback?
Gain after feedback.
Yeah. How much feedback do you?
Oh, I don't know. I honestly don't.
15, 20?
As much as I can put in there.
Right.
I mean, it isn't like I design it for most gain boost. It's the circuit does what it does. I don't throw it away. Now with now I build an a preamp, and it used to cost about 4 times as much as this. It doesn't use any feedback. And that's what I use at home. But nobody can afford it, you know.
You have to kind of like
And it measures lousy compared to.
You have to like the distortion that comes out.
Well, it doesn't have that much distortion, but it does have some.
Got some.
Oh,
feedback
yeah.
would cure it,
But feedback, it's hard to make feedback acceptable.
the downfall of feedback is non-constant phased response clear through the bandpass.
Well, it's what we think it is FM distortion now. That's the latest, yeah.
Same thing.
Question about the THX. Is it just a certification, or is it more to it than that? Or?
Well, they test the things, and they kind of approve it or don't approve it. You know, they maybe give us some feedback on what they want. Some of their standards are kind of silly. In fact, that's one of the reasons they use so much feedback, is because they demand, you know, like, what is it, 0.1% at 20,000 hertz at full power or something. It's like, you know, I got to make it. I got to make the nut, you know. I mean, it's like the only way I can do it, as linear as I can make the thing, I still got to use feedback to be able to make the spec. And it's hard to do both.
I'd like to, I've worked with Century Stereo for 20 years selling various products as a manufacturer's representative, and I was very interested by the gentleman's comment about, you know, MP3 and how people are going to, you know, where are we going to get our new customers? Because he makes a very good point. My suggestion is if you have children, take them to a live concert and let them to listen to live music for the first time, and let them hear the difference between a compressed MP3 earbud and a real performance. And once they do that, and once they hear that, they might get it. Because stores like this, if we keep going down the road that we're going, won't exist. So you won't be able to bring them here and have them sit down and listen to a really good presentation of somebody who sets something up properly, nicely, and knows how to do and present a demonstration.
Jeffrey, thank you, because that's what we're going to do now. You ought to have an opportunity to hear what we've been talking about. Some of you own this equipment, some of you haven't heard it. I'm holding something that says Roy Demo. So I think I'll put that on. I don't know, what is it? What's the material? I mean,
4, 12, 17.
Good, knock yourself out. Well, we've got a JC2 Halo preamp, which is John's creation, the JC1 amps, which he's talked about. The CD1 was a collaboration between us and Home Acoustics in Denmark, and it's actually the only kind of CD player of its kind in the industry, and it's the only CD player that will play bit perfect, that will output bit perfect signal. It makes 44.1 sound quite extraordinary. And these are wonderfully balanced Paradigm speakers. I couldn't even lift these if I had to. They're so solid. You'll have an opportunity to hear the really low bass, the kind of authority and extension without exaggeration that I was talking about in the beginning, and a kind of a neutrality that you might not have heard in a lot of systems before this. So let's see what we've got.
write away letter. I gotta mail it today, straight to my main inspirer. Says urgent from the USA. It's got this heart in sight. The postage is my soul. Contains a message for millions. Say, kid, don't go. 10,000 guitars waiting, but it ain't quite the same. You got a knack for sailing, and it's stamped with your own brand name. We's all sailors, as captain you must know. You bring a message to millions. Say, keep don't go. I said, keep don't go. Oh, don't take my fun. Keep don't go. Keep don't go, nah, nah.
With all due respect to Niels Lofgren, I'm going to change it up just a little bit. This is O Holy Night in German. It's a Proprius recording that's out of print. This is a copy. It might play.
And if not, you could hear it at 25 audio shows.
Yeah, if we can go to something else. I mean, it's a great recording.
I think it's amazing because you can hear the cathedral it's in. You know.
Okay, maybe it's Danish.
Let's take a quick break, and why don't we do the raffle?
Okay, you want to
Take a little
do the
break,
raffle?
yeah. All right, 83